Yes,
All
sir.
right. All right. So now you should all see my whiteboard, right?
Yes, sir.
All righty. So let's talk about what we talked about the other day. All right. The other day we talked about what?
Radius, circumference.
We talked about circumference, right? But before we even talked about circumference, we talked about what is a circle. We talked about what's a radius. We talked about what is a chord. We talked about what is a diameter, right? Yes?
Yes.
Now, what's the problem when we talk about a circle and trying to take measures? What's the difference between a circle and some of the other things we've talked about? A circle is curved, right? So it gets it really hard to measure or take measurements when the circle is not made up of line segments. It's made up of a curve. So what we do is we use these words, right? And what they mean, because these are all different types. These are all different types of line segments. Yes? All righty.
Yeah.
So we know that you need to know the definition of all of those, fellas. So, for example, right, if I said to you, what's a circle? Well, what's the definition of a circle? All the points in a plane equidistant from the same point called the center. You need to know that definition backwards and forwards. What if I asked you, what's a radius? Well, a radius is a line segment. So it's part of a line whose two endpoints, one of them is the center of the circle, and the other one is a point on the circle. All right? A chord is another type of line segment, but in a chord, the two endpoints are on the circle. And then finally, a diameter. A diameter is a special type of chord. It's a chord, which means its two endpoints are on the circle, but in a diameter, it has to pass through the center, right? I don't know who it is, but you guys need to mute yourself because I'm getting an awful echo, all right? All righty. So let's look at this in a picture. What would I call that circle? I would call that circle circle A, because we always name the circle from the point that's the center. All righty? So if I drew this line segment, what would you call line segment AB? Well, line segment AB is a radius. How do we know it's a radius? Because it's two endpoints, A and B. One of them is the center of a circle, and the other one is on the circle. How many radii are there in a circle? Well, there's an infinite number of radii. So there's another one, 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 there, and so on. I can do that all day long, right? All right? Now, what do you know about all those measures? They're all what? All those
Equal.
radii, they're all the same measure. Very good, because that's the definition. All right, now let's look at another type of line segment we talked about. I'm going to call this CD, right? And that's a chord, right? CD is a chord because we know that its two endpoints are points on the circle. So that's a chord. Now, every once in a while, you will get a chord EF. Every once in a while, you'll get a chord that actually goes through the center of the circle. And that, gentlemen, is what we call a diameter, right? So that's something you should all know, right? You guys knew that already though, right? Yes, no, maybe?
Yes.
All righty. So then we introduced the relationship between a radius and a diameter. Because I know that this yellow line segment is a radius. And I know this blue line segment is a radius. But if I put those two together, this is a radius, this is a radius. What is AB? It's a diameter. So AB, this is a diameter. So here's what I know. A diameter has to be 2 times the radius. And I know that a radius then would be the diameter divided by 2. So if I know one, I know the other. So like a lot of what you do in math, fellas, is actually understanding that you know something, but then actually knowing what else that leads you to know. So if I tell somebody that their diameter of the circle is 10, if I told you AB equals 10, somebody tell me what, if this is C, somebody tell me what CB equals. Well, what's CB?
5.
Yeah, it's 5 because it's a radius. And what's the radius? The radius is the diameter divided by 2. So if I tell you the diameter is 10, I divide it by 2, what do I get? I get 5. That makes sense? Yeah, you guys knew all that, right? Yes, no, maybe? Hello?
Yes.
All righty. All right, so then we then took that information and then we expanded it to start talking about circumference. What's circumference? If I ask you for the circumference of a square, does that make any sense?
No.
No. What do you find in a square? What do we call the distance around a square or a rectangle or a triangle or a parallelogram? What do you call that? Hello? Is it called the perimeter?
Yeah.
Yeah. So that's a square, right? And I tell you that side is 9. What's the perimeter? Well, how many sides are there in a square?
36.
So there's only 4 sides, but 9 times 4 is 36 units, right? And that would be your perimeter, right? Now, we don't talk about a perimeter in a circle because a circle is not made up of line segments. A circle is a curve. So if we didn't have those line segments we talked about earlier, diameter and radius, it would be really difficult for us to find the circle. So we take the diameter and or the radius, and that will convert to circular. And all I need to know is the formula. So the circumference is pi times the diameter. But sometimes they don't give me the diameter, they give me the radius. Well, I know the radius times 2 is the diameter, so 2 pi r. You can use either one of those based on what they've given you, what type of information they've given you. Does that make sense? Yes, no, maybe? So if I give you this picture and I tell you this, and I said to you, what's the circumference of circle A? Well, what did I give you? What line segment did I give you? What's AB?
Radii.
It's a radius. Good. So I'm going to just go like this. Circumference is 2 pi r, because 4 is r. So I'm just going to take my 4 and substitute it into the formula. 2 pi times 4. And then I end up with what? 2 pi. Now, if you leave pi as the symbol, that would be an exact measure. But most of the time, we're just going to approximate. So what am I going to change pi to? What's the approximation for pi?
3.14.
Yep, 3.14. And then 2 times 3.14 is 6.28.
Something.
I did that totally wrong, gents. Didn't I? What's 2 times 4? How did none of you see that? What's 2 times 4?
8.
8 pi. I put 2 pi. Not one of you corrected me. What's going on? So then I go 8 times 3.14. What do you get?
That would be
8 times 4, 32. Carry 3. 8 times 1 is 8, and 3 is 11. Carry 1.
5.12.
All righty. Hey, fellas, when I make a mistake like that, you got to correct me. Does that make sense?
yes, sir.
All righty. Not that big a deal, right?
Nope.
Now, of course, if I give you the circumference, you should be able to tell me the diameter or the radius just using the same formula. All right, so now today, we're going to talk about central angles and arcs. Okay? So we're going to have to know how to classify. All right? We're going to have to know classify, and then we're going to go find measures. All right? So today we're going to talk about central angles and arcs. So we're going to have to learn how to classify, yes, this is a central angle. This is a minor arc, a major arc, semicircle, right? And then we're going to go find measures. So that's what we're going to do today. It's not really that hard, but we just got to go through it nice and orderly so we know what we're doing. All righty? So remember, we're dealing with circles, right? So there's my circle. That's point O. So let's make it B. How about we make it B? Let's just make it easy for ourselves. So that's circle B, right? Now, that's A. That's C, right? So if you look carefully now, there's an angle, right? So this would be called angle ABC. What else could you call it? Could you call it angle CBA?
Yeah.
Yes, you could. Could you call it angle BCA?
No.
No. How come you can't call it that? What do you notice about the top two?
They're on the circle.
What has to be in the middle? What
The
has to be in the
vertex.
middle? The vertex. Very good. All right. So just make sure of that. So you can have the same angle, and two different guys give you two different, permutations. All right. So now, I'm going to tell you this is angle ABC, and I'm going to tell you that angle ABC is what we call a central angle. Now, without me telling you the definition, based on what I just said, what's the definition of a central angle then? Go ahead. A central angle is any angle whose vertex is the center of a circle. So what's the vertex of angle ABC? It's B. Well, if you look at that picture, fellas, what's B? The center of the circle. So angle ABC then becomes a central angle. All right, does that make sense?
Yeah.
Yes or no? All righty, let me get rid of all of this. All right, now, what does every angle have? What does every angle have? What does every angle have? I just drew one.
A vertex?
Yeah, but what's that red mark there, right?
Vertex.
Uh,
A measure.
Thank you.
uh,
Every angle has a measure, all right? Comprende? Let's get this B out of there for a second. Now watch. I'm going to draw a whole pile of angles for you. Now, I'm going to rename this angle number 1. I'm going to make this angle number 2. I'm going to make this angle number 3. I'm going to make this angle number 4. Hey, fellows, what do you know about all of those angles? Every single one of them is what kind of angle? We just introduced it. Where's the vertex? Where's the vertex? Each of those angles, where's
In
the
the middle.
vertex?
in
The center
middle.
of the circle. So that makes each of those angles a what?
Radius.
A central angle.
Uh,
We're not talking about the sides. We're talking about the angles. Hey, fellas, how many degrees are in a full circle?
360.
360.
So what do you think is the answer to this question? The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. What do you think the answer is?
360.
360 degrees. Does that make sense? Here's what you need to know.
Yes, sir.
The sum of the measures of all the central angles of a circle with no common interior points is 360. All righty? So let's see what that looks like if we wanted to use that information. So there's a circle, right? There's my center, right? I'm going to draw you this, all right? Let me see. I'm going to try and draw it nicer, right? All righty. So here's point G. Here's point H. Here's point J, right? And here's what I know. I know that this is 90, and I know this is 130. There's the center of the circle. If I said to you, what's X? How would you do that? Well, what do you know about all the central angles? What do they have to add up to?
360.
All righty. So I already know 2 of the 3, right? So one of them is
Yeah.
90. One of them is 130. And one of them, I don't know what it is. But I do know that if I add all of them up, I get 360, right? So if I add 130 and 90 together, what do I get?
220.
220 plus X has to equal 360, right? Now, get X all by itself. What would you do?
Subtract 220 from both sides.
Thank you. And then you end up with X
140.
equals
40.
140, right? 140 degrees, right? Does that make
Yeah.
sense? All right. Let's do another one of those. Let's do another one. Same idea. Just give you different numbers. There's the center of my circle. All right, I'm going to tell you that. I'm going to tell you this, and I'm going to tell you this, and I'm going to say, what's x? Well, what do you know about all four of those angles? They're what? What kind of angles? What kind of angles are they?
Central.
Central angles. So when you add them all together, what should you get?
360.
Alrighty, so let's do that. So the measure of angle x plus 90 plus 40 plus 85 has to equal 360, right? So the measure of angle x, now, if I combine all my like terms, 90 plus 40 plus 85, that gives me what? 215, I believe, right? Is that right?
Yeah.
All righty.
Yeah.
Now, get x by itself. What do you do to both sides? Subtract 215. And I'm left with the measure of angle x equals 145. Now, if I put 145 in here for x, and I add all four of these angles together, do I get 360? Yes, I do. Does that make sense?
Yeah.
All right, not that big a deal, right? All right, so all we did was we introduced the idea of a central angle. And we know that all the central angles of a circle have to add up to 360 because a full circle means 360, right? All righty. So now we're going to go a little bit further. Now we're going to introduce the idea of an arc. All right, now you got to pay attention for about 10 minutes. All right? Now, what is an arc? An arc is part of a circle. And it has two endpoints. Now, arcs are different than line segments because they're curved, all right? So, for example, if I take this circle here, ready? And I put an endpoint here and an endpoint here. Here's the arc. There's an arc right there. Does that make sense? Notice two endpoints, and it's part of the circle. Hey, who sees the other arc? Can I go the other way?
Yes.
Yeah. So here's what you need to remember. An arc is part of a circle from one point, we call an endpoint, to another endpoint. But in a circle, you can go both ways. So there must be some way that we can talk about, oh, which way are we actually talking about? Does that make sense? All righty.
Yeah.
So now let me clear this. And I'm going to draw you a nice little circle. Ready?
Coach,
Yes.
may I go to the bathroom?
Go ahead.
Thank you.
So here's my circle, and I'm going to draw you this angle. Now, somebody tell me, right? I'm going to call this circle B. Okay? Somebody tell me what kind of angle that is. Somebody tell me what kind of angle that is. Where's the
That's
vertex? Where's
the
the
middle.
vertex? It's the center. So
Yeah.
if it's the center, what do we call it? If your vertex, it's a central angle, yes?
Yes.
Yeah.
Now look what it does to my circle. That's an arc, right?
Yeah.
Yes? What's this? This is an arc too, right? Going from A to C. But what's the difference? One's a hell of a lot longer than the other one, right? Yes? Yes?
Yeah.
So there's the first thing you got to remember. The shorter arc is called the minor arc. The longer arc is called the major arc. Well, if I said to you then, here's the problem you might have. The endpoints are still the same points. So if I said to you arc AC, how do you know if I'm talking about the minor one? How do you know if I'm talking about this one from A to C? Or if I'm talking about this one from A to C? Here's how you do it, right? If you're talking about the way from A to C that's the shorter, you just use A and C. But if you wanted to talk about from A to C this way, all you would do is pick some point out here. And you would simply go like this. A, D, C. And all that means is arc AD. All this means right here. All this means is arc ADC means start at A, end up at C, but go through D. Does that make sense? Does everybody understand the difference between this and this? Yes or no?
Yes.
Yeah.
All right. So here's what you know. You're going to erase the picture. You're going to draw you another one. When you have a central angle, it's going to cut the circle into two arcs. The shorter one is going to be called the minor arc. The longer one is going to be called the major arc. All righty? Does that make sense? Now, a minor arc is always going to be, all right, I'm starting to get ahead of myself. Sorry about that. All righty, so far so good? So far so good?
Yes,
Yeah.
sir.
All righty. So let me ask you one question. Let me give you a picture. I'm going to ask you a question, right? Here we got circle, right? This is going to be circle Q, right? And I'm going to give you, this is P, this is R, and I'm going to make this S. Somebody tell me, so is Q, is angle PQR central? Yes or no? Is angle PQR a central angle?
Yes.
Yes. Okay, good. So somebody tell me then, which arc is the minor arc? Which arc is the minor arc? Which arc is the major arc? Well, we know that it cuts it into two. There's one arc.
That's one.
And where's the other arc? Here's
The
the
big
other
one.
So which one is this? Yellow or blue?
Blue. Or no, that's yellow.
That's the yellow one. That's what we call the minor arc. How come we call that the minor arc? Because that's the smaller one. This one here is the blue one, and that we call the major arc. Does that make sense to you guys? Hello? Hello?
Yes.
All righty. Now, here's what we know about arcs. Arcs have what we call measure. They also have a length, but we're not going to get to that until next week. If we talk about the measure of an arc, all right, now pay attention. Angle, we said, central angles always add up to what? If you took those four angles and added them all together, what would you get? They add up to?
360.
360. Why do they add up to 360? Because a full circle is?
360.
Hey, fellas, do you know why they made a circle 360 degrees? They could have made it 100, like when they were inventing it. Did they invent it or did they discover it? 360 is a great number because a lot of numbers go into it. Ready? So look at angle 1. Ready? That's an angle. Somebody guesstimate like what that would be. I think it would be about 85 degrees. Now, the arc AB, the minor arc, this is the minor arc, yes? Hello?
Yeah.
AB, that's the minor arc. What would you call the major arc?
ACB.
Okay, good. Now, each of those arcs has a measure, right? So, this arc right here has a measure, right? And I'm telling you, it's 85 degrees. Somebody tell me what's the rule for the measure of the minor arc? What does this look like? What's it look like? Hello? This is the central angle, right? So the minor arc is equal to the central angle that cuts it. Now let's see who knows how to think. Fellas, if from here to here is 85, what is it from here to here? Anybody know? How do you think you'd figure it out?
275.
How'd you do that?
I subtracted 85 from
What's a
360.
fellas, what's a full circle?
360.
360 degrees. Well, I already know this is 85, so I just subtract that from 360. And then what do you end up with? Yes? Agreed? So
Yes, sir.
this would be 275. Does that make sense?
Yeah, that's right.
Huh?
Yeah, 75.
Yep. Does that make sense? So all you
Yes, sir.
got to remember, what you got to remember is this. A central angle and the arc it cuts or intercepts is going to have the same measure. The full circle, the arcs of a full circle have to add up to 360. Try this one. Let's try another one. Try this one. I'm going to give you a circle. This is G, K, J, all right? This is H, and this is L. And here's what I'm going to tell you. I'm going to tell you two things. GJ is a diameter, all right? And then I'm going to tell you this angle right here is 122 degrees, all right? Now, why is it important that I told you that GJ is a diameter? You're going to find out in a second. Ready? Fellas, tell me what is the measure of arc GH? What's the measure of arc?
122.
It's 122, right? Because it has
Yeah.
to be the same. This arc has to have the same measure as the central angle. Hey, fellas, I told you this is a diameter, right? So if this is 122 here, what's this? This is the diameter. Straight line. 122 here. What does this have to be? Well, what do you know about this one and this one together?
They equal 180.
180. So 180 minus 122 equals what?
58.
58 degrees. Good. Now, what's arc? What's arc HJ?
$58.
How come it's 58? Because it's got to be the same as
The central angle.
the central angle that cuts it. Very good. Everybody following? All right.
Yeah.
Here's a question for you. What is the measure of arc GLJ? Well, what's that mean? Start at G and go to J, but go through L. Hey, fellas, what is this? It's a diameter, right? What's the measure? What's the measure? What's the measure of a straight line?
180.
180. So this would be 180. Now, fellas, notice 122 and 58 is 180 as well, right? So if your arc measure is 180, we don't call that a minor arc or a major arc. A minor arc is less than 180. A major arc is greater than 180. If your arc is equal to 180, we call that a semicircle. Okay? Does that make sense?
Yeah.
All righty. $64,000 question. Ready? See who can put this stuff together. Ready? If I said to you, what is the measure of arc HGJ? Go. What's the measure of arc HGJ? Start at H and go to J, but you got to go through G. What's the measure of that arc?
360.
H to J is 360?
No.
Nope. H to H is 360. H to J would be what? Well,
302.
well, it would be 360, a full circle, minus the part that I'm not counting, 58.
302.
So I would get 302. Does that make sense, fellas?
Yeah.
That makes total sense, right? So just like the central angles have to add up to 360, all the arcs have to add up to 362 because that's what the circle is, right? Let's do one more before I cut you loose so you can enjoy your weekend, all right? All right, so here's what we know. This is 90. This is 115. And this is 65. All right? Comprende? So,
Yes.
if I said to you, what is the measure of arc MQ? Well, my first question to you, is that going to be a minor arc or a major arc?
Minor.
Less than 180 or greater? What's MQ? What's the measure of MQ?
65.
65. Why? Because that's the measure of the central angle that cuts it. Does that make sense? What about this one? What's the measure of arc MNP? All right. Start at M, go to P, through N. What's that? What does this angle have to be, fellas?
That angle
I
is
can't-
90.
What does this angle have to be? Right here. How come that has to be 90? What's 115, fellas? What's 115 and 65? That's 180, right? So if that's
Yeah.
180, so is this. I told you this was 90. That's 90. So what's this arc? What's 90 and 90? 180.
180.
Yeah. From here to here is 180 degrees. Right? Now, last question. What's the measure of arc M and Q? So I'm going to go from M to Q, but I'm not going to go the short way. I'm going to go the long way. I'm going to go from M to Q through N. All right.
295.
Well, if I went from M to M, that would be 360, right? So
Yeah.
360 minus the part I already know. This is 65, so I'm going to subtract that, and I'm going to end up with what? 295. Does everybody follow that?
Yep.
Yeah.
I don't think it's that big a deal, right? Hello? All righty. So here's what we know. Sometimes we have minor arcs. Sometimes we have major arcs. Sometimes we have what we call semicircles. And those are all cut by central angles. A minor arc will always be less than 180. A major arc will be greater than 180. And a semicircle will be equal to 180. And it's and the minor arc is always going to be the same measure as the central angle that it cuts. And if you add up all the central angles of a circle, what do you get? You get 360. Does that make sense? Hello?
Yes.
All righty. So that's what you're going to work on today, right now. Just so you know for next week, this is what we're going to talk about next week. We're still going to talk about arcs. So if I told you this was 60 degrees, what's the measure of arc AB? What's this measure? What would this arc measure? 60, right?
Yeah.
Yes or no?
Yes.
All righty. Well, what we're going to do next week, we're not going to talk about the measure of it. We're going to talk about the length of it. So the measure of it might be 60, but the length of it, well, that could be what? That could be 5 feet, right? So that's what we're going to do next week. But that's not what we're doing now, all right? That's what we're going to do next week. We're going to talk about the length of an arc. All right? So far, so good? All righty. So here's what's going to happen. I'm gonna put in your make sure you hand in your homework assignment today. All right? And then I'm gonna put in Blackboard a little worksheet on arcs. All right? And then all you got to do is just make sure you only do the problems I ask you to do. And that's got to be submitted by 11:59 p.m. tomorrow night. Does that make sense?
Yes.
Yep.
All righty. So far, so good?
Hey, Coach,
Yes.
what about our test?
Yeah, I'm going to have that mark. I had a lot of trouble. I had some guys emailing me the thing, so I'm downloading it and then copying it. So that'll be up by this evening, all right?
All right, thank you.
All righty? All righty. Anybody have any problems? Anybody have any questions? All righty. You guys have a good weekend, all right?
All right.
All righty,
Have
all
a
the
good
best.
one.
All right, see you later.